everyone, it's Miss Besega, and today we're working on polarized light. The reason we're out here in this beautiful sunshine is because there are lots of animals that can see and experience polarized light, but you and I, we can't, or at least without help. So, the glasses I currently have on, their job is to help not only block out 50% of the light, but they also filter what's called polarized light. So, for today, grab your notebook, whatever it is you're using to take notes, and let's get to it. In order to understand polarized light, an important thing you have to remember is that light is a wave. But not only is it a wave, it's a very specific type of wave called electromagnetic. In this type of wave, you have an electric field. In this case, the electric field is oscillating right and left, right and left, right and left. Whereas your magnetic field is oscillating up and down and up and down, perpendicular to the direction the wave travels. Now, the reason that this is important is because this is a doubly transverse wave. It's transverse in both the x direction, left and right, like the pink, and the y direction, up and down, like the blue. Because it's transverse, it can be polarized. Sound, however, cannot be polarized because it's a longitudinal wave. Now, most of the light you encounter in your daily life, most of that light is unpolarized. And that means each photon of light has its oscillations in all different directions. While some have their electric field oscillating right and left, like the picture on the previous page, well, some have their electric field oscillating up and down, and some are oscillating sideways, and some are just random. Unpolarized light is the word for light that has no specific up and down. All of the different electric fields are oscillating in different directions. This type of light spreads out in all directions, and lots of times, unpolarized light comes from sources that are using heat to generate lots of light at a time, like sunlight, for instance. All of the reactions inside the sun are random, therefore all of the electric fields are oscillating randomly. With incandescent light bulbs, they heat up, and because of that heat, those particles are oscillating faster and faster and emitting light, but randomly in all directions. Same with LEDs, though with a little bit of a different mechanism, and fluorescent light bulbs. So that most of the light you experience in your daily life is unpolarized. But some light that you experience is polarized. So polarized light is light in which all of the waves oscillate with their electric field in the same direction. So let's say I had horizontally polarized light. That would mean that all of the electric fields were oscillating right and left, and there weren't any oscillating up and down. If it's vertically polarized light, like this picture, sometimes you'll see it drawn as just the electric field oscillating up and down. We know the magnetic field is there, but we're not going to draw both. That's just extra confusing. And examples of light that is polarized include computer screens, phone screens, and reflection off nonmetals, which we're often going to call glare, like the glare on the side of this building here. So to sum up, how do we draw unpolarized versus polarized light? I would draw unpolarized light as the electric field oscillating randomly in all directions, like sunlight. Whereas polarized light would be light that's oscillating all in the same direction. Now, you might be thinking to yourself, reflection off nonmetal, that sounds awfully specific, Miss Besega. But what I want you to think about is that because of reflection, when unpolarized light hits this nonmetal surface here, well, the vertically polarized light, the light waves that electric field was bouncing up and down for, well, those get stopped by the metal. They actually get absorbed by the metal, causing the metal to gain energy and heat, which we know occurs when light hits metal. But the horizontally polarized light reflects off. So the rule for reflection off nonmetal surfaces is that when unpolarized light hits it, the polarized light reflects off parallel to the surface. So let's say I have a puddle of water. Well, that light would be horizontally polarized because the surface of the water is horizontal. If I had something like, ooh, gross, the oil on my forehead, ooh, that's the reflection off a non-metal, so the glare you're seeing right up here from the sun, great. Yeah, that's vertically polarized because the sunshine is hitting my head, so the sunshine is unpolarized, hits a vertical surface, and then is then vertically polarized afterwards.